Hello dear student, welcome to our new session of motion in straight line. Motion in straight line. This is our 8th lecture. Now we'll cover all the fundamental equations of motion. We'll cover equations of motion with constant acceleration. We'll cover what actually trajectory is, what are the equations of trajectory. Now we'll start with our new topic called motion under gravity. This kind of motion is also called motion along y-axis. This motion is also called, I'll write here, or we'll say motion along the y-axis. Motion along the y-axis. In motion in straight line, the topic is motion under gravity, or we can say motion along the y-axis or motion under gravity. Now see my dear student, if I am standing here and I'll throw a ball in y-axis, see, we know that this is our y-axis and this is our x-axis. X-axis and y-axis. So if motion is only along y-axis, remember my dear student, if the motion takes place only along any of the axis, either it will be along x-axis or it will be along y-axis or it will be along z-axis, all these kinds of motion is considered to be in motion in straight line, or we can say motion in one dimension. So here nothing will be changed, just the direction of motion. Instead of x-axis, we are now motion will be performed along y-axis, that's it. Other else the motion is straight line, motion is one dimension, just the motion is moving, the particle is moving along y-axis. That's why I am saying here that motion along y-axis. So motion along y-axis is also an example of straight line motion, or we can say one dimension motion. So moving forward, let's suppose I'll throw a particle in upward direction like this. If I'll throw a particle like this, then this motion is basically nothing but motion along y-axis. Now why we'll say motion under gravity instead of motion along y-axis, or why we'll say motion under gravity? Simple, understand this thing beta. Actually, if I'm throwing a ball in upward direction, or we can say particle is moving along y-axis, in that case my dear student, the only acceleration which is acting on particle is acceleration due to gravity. I'll write in form of note, if the particle is moving along y-axis, then the only acceleration which is acting on particle is acceleration due to gravity. And I hope you all know about acceleration due to gravity. The acceleration due to gravity is nothing but g, and we know that g is basically constant term and its value is 9.8 meter per second square. We'll take, instead of 9.8, we'll take 10 meter per second square. So we'll say the value of g is approximately equals to 10 meter per second square. So remember my dear student, if any particle is moving along y-axis, then remember this thing, the only acceleration which is acting on particle is acceleration due to gravity, and the direction of acceleration due to gravity is always vertically downward. I'll write here the direction of acceleration due to gravity, that is g, is always vertically downward. downward. That's why, my dear student, motion along y-axis is also called motion under gravity, because the only acceleration which is acting on particle is acceleration due to gravity. Remember this thing, the only acceleration which is acting on particle is acceleration due to gravity, and the direction of acceleration due to gravity is always vertically downward, and its value is g, and we know that the value of g is 10 meter per second square, or we can say 9.8 meter per second square. Its direction is always vertically downward. So if I'll say the particle is moving along y-axis, then the only acceleration which is acting on particle is g, and its direction is always vertically downward. This basically, this note is very much important, and this is the only concept which is used in motion under gravity, my dear student. Remember this thing, I am repeating again and again, that if the particle is performing motion along y-axis, then that category of motion is considered to be motion under gravity. And meaning of motion under gravity is nothing but, it is why motion under gravity, because this motion is basically achieved under the constant value of acceleration, and the only acceleration which is acting on particle here along y-axis motion is acceleration due to gravity. Remember this thing, my dear student, the value of acceleration due to gravity is basically constant, and its value is 9.8 meter per second square. And remember this thing, acceleration due to gravity is always acts vertically downward, always acts vertically downward. That's why, my dear student, if I'll throw a particle in upward direction, then it reaches a maximum height and come back again. Why, my dear student? See, in first case, if you'll throw a particle in upward direction, then its direction of motion is upward. At certain height, it achieves its maximum height, and at that point it become in condition of rest and then come back. Then its direction of motion changes. It is only happened if the direction of velocity and acceleration is opposite to each other, then only it happens. That's why if I'll throw a particle in upward direction, it achieves a maximum height and again come back, And remember this thing, my dear student, if motion of the direction of motion changes, it means the direction of velocity and acceleration is different. Remember this thing, opposite to each other. This is very important point. Write down in terms of note that if the motion of direction, this is very important point. I'll write here in form of again note. If the direction of motion, of particle changes, it means it stops at certain point. It is very much compulsory that, my dear student, if any particle changes its direction of motion, it implies it stops at any point, because without coming at rest, the direction of motion never changes. The direction of motion only changes if particles stop and then change its direction of motion. Without coming at rest, particle direction of motion never changes. That's why I'll write here, if the direction of motion of particle changes, it means it stops at certain point. Now moving forward, if particle changes its direction of motion, it implies the direction of velocity and acceleration. The direction of velocity and acceleration must be opposite to each other. This is very important point, my dear student. First thing, without taking at rest condition, particle cannot changes its direction of motion. First thing. Second thing, if particle changes its direction of motion, then it is very mandatory, it is but obvious that the direction of velocity and acceleration is always opposite to each other. If direction of velocity and acceleration cannot be opposite to each other, then the speed of particle increases. So in that scenario, particle never stops, my dear student. If you wish your particle to be at rest condition, then it is must mandatory that the direction of velocity and acceleration becomes opposite to each other. Only in that situation the speed of particle decreases and at certain point it come to be in rest condition. So remember this thing, my dear student. Along y-axis, if I'll throw a particle, then the particle achieves some maximum height, come to rest and then change its direction of motion. This only happens due to acceleration due to gravity, which always acts vertically downward on particle. So I hope you all understand this concept, that if particle is changes its direction of motion, then it must stop at certain point, then only the particle changes its direction of motion. Second thing, if particle stops, or we can say if particle is changing its direction of motion, in that case at certain point the particle must come to in rest condition, and if particle is coming to rest condition, it implies the direction of velocity and acceleration which is acting on particle is always in opposite direction. Without acceleration and velocity to be in opposite direction, nothing will stop, because if direction of velocity and acceleration which is acting on particle is in same direction, then the speed of particle increases. Remember this thing. If, write down again in form of note, that if the direction of velocity and acceleration, if the direction of velocity and acceleration is same, if the direction of velocity and acceleration is same, then the speed of particle increases. Then the speed of particle increases. And if the direction of velocity and acceleration, and if the direction of velocity and acceleration is different, and if the direction of velocity and acceleration is different, then speed of particle decreases. Then speed of particle decreases. So remember this thing, without come to rest, particle cannot change its direction of motion. Second thing, if velocity and acceleration both are in same direction, then the speed of particle increases. In that case, particle cannot stop, because for coming to rest condition, for coming to be at rest, for coming to be in stop condition, the speed of particle must decreases gradually. So if you want to stop the particle, then at certain time the velocity and acceleration must be in opposite direction, then only particle stops. If velocity and acceleration are in same direction, then it is not possible for particle to stop, because in that condition the speed of particle increases. So if speed increases, then it is not possible to particle to be at rest condition, or we can say particle come to be in rest condition. So I hope you all understand this normal condition of motion. Now come to our point, or we can say come to in topic, that which is motion under gravity, or we can say motion along y-axis. So remember this thing, my dear student, if particle is performing motion along y-axis, then remember this thing, the only acceleration which is acting on particle is acceleration due to gravity, and acceleration due to gravity means g is a constant value term, and its value is approximately equals to 10. If you want to take its actual value, then its actual actual value is 9.8 meter per second square. See, meter per second square is the SI unit of acceleration. That's why G is said to be acceleration due to gravity. So remember, it is very important to understand that if particle is performing motion along y-axis, which is also called motion under gravity, then the only acceleration which is acting on particle is acceleration due to gravity, and its direction is always vertically downward. Now we'll discuss different cases on motion under gravity. So write down very first case. A body is throwing from ground. A body is case first under motion under gravity is a body is throwing along y-axis from the ground. My dear student, this topic is very important, very sensitive topic, because this topic connect you in next chapter, that is projectile motion, or we can say motion in plane. So try to understand each and every concept which I'll explain in this video. So case first is a body is throwing along y-axis from the ground. Now see, my dear student, let's suppose this is the ground and a particle is throwing in upward direction along y-axis. So I'll make a particle which is throwing along y-axis. So we have a particle like this and we are throwing this particle in upward direction. Now see, my dear student, if you are throwing anything, it implies you are giving some velocity to the particle. Throwing means giving some velocity to the particle. Remember this thing. Throwing means nothing but to giving some velocity to the particle. Giving some velocity to the particle. We have two different words. One is dropping and one is throwing. In dropping situation, we cannot give any velocity to the particle. In that case, initial velocity is considered to be 0. Remember, if I am saying word dropping, it means in physics that the initial velocity of particle is 0. But instead of dropping, if we are using word throwing, then throwing means we are giving some velocity to the particle. So if particle is throwing, then its initial velocity never equals to 0. So write down in form of note that, I'll write here in form of note, if a particle is throwing, then its initial velocity never equal to 0. I hope you all understand this thing. If a particle is throwing, then its initial velocity never equals to 0. But if you are dropping a particle, in that case you will consider initial velocity of particle to be 0. So in this situation, my dear student, I am standing here and throwing a particle. If I am throwing a particle, it means I'll give some initial velocity to the particle. So remember this thing, my dear student, if you are throwing any particle even from ground or from building anywhere, then in that case initial velocity never equals to 0, because throwing itself means giving some velocity to the particle. And if you are dropping any particle, in that case the initial velocity is always considered to be 0, because for dropping we cannot put any velocity to the particle. That's why if particle is dropping, remember initial velocity is equals to 0. If particle is throwing, initial velocity never equals to 0. So we are throwing a particle. So if I am throwing a particle in y-axis, along y-axis, my dear student, then we are giving some velocity to the particle. Then only particle starts performing motion. Because without giving some velocity, it is not possible for particle to perform motion. So I am giving some initial velocity. Let's suppose I am taking initial velocity to be v0. I'll write here, let a particle is throwing in upward direction, that is along the y-axis, that is along the y-axis, by giving some initial velocity is equals to v naught to the particle, So my dear student, I am taking initial velocity to be v naught. Now see my dear student, this motion is nothing but motion along y-axis, and I already tell you, if particle is performing motion along y-axis, then it is but obvious that only acceleration which is acting on particle is acceleration due to gravity, and its direction is always vertically downward. So next point, the only acceleration acting on particle is acceleration due to gravity, which always acts vertically downward. So the only acceleration which is acting on particle is acceleration due to gravity, which is represented by g, and its direction is always vertically downward. Now see my dear student, the point from where particle started its motion is always considered to be origin. This is the basic concept, which these things are basic concept which you have to remember, then only you will solve the numerical. Otherwise for you it is not possible to solve the numerical for motion under gravity topic, because it is quite complicated topic, not tough but quite complicated. So this is the point from motion, from where motion started. So I take this point as origin. Origin means the point where value is 0, 0. Now see my dear student, if we will see above origin, all the value is positive, and we know that below origin all the value is negative. So see, this initial velocity is in positive direction my dear student. That's why I'll take initial velocity to be positive, and the acceleration, which is only acceleration due to gravity, is in downward direction my dear student. That's why I'll put g, along with g I'll put a negative sign. This negative sign implies that the direction of acceleration due to gravity is vertically downward. See, I am taking this point to be origin, and we know that above origin all the value is positive and below origin all the value is negative. So if we are seeing here, then the acceleration due to gravity is below origin. The direction of acceleration due to gravity is vertically downward. It means its direction is below origin. That's why I'll take negative sign along with g, and this initial velocity is above origin. So if initial velocity is above origin, then we know that above origin the value is always positive. So I'll put initial velocity with positive symbol, and acceleration due to gravity is of negative sign, as acceleration is vertically downward. Its value is g, and along with a negative sign. Now see my dear student, I'll write here the point from motion, the point where motion starts is always considered to be origin. I'll write here the point from where motion starts is always considered to be origin. And remember this thing my dear student, above origin all the value is positive, and below origin all the value is negative. That's why initial velocity is considered to be positive and acceleration due to gravity is considered to be negative. Minus g, will always consider acceleration to be minus g if the motion is under gravity, or we can say motion is along y-axis. Now moving forward, I'll write all the equations of motion when the particle is moving in positive y-axis, if the particle is throwing from ground. So my dear student, see, if I'll throw this particle, it achieves certain height. and again come back towards ground. We know that this is the very fundamental, process. If you'll throw any particle in y-axis, then it achieves certain height and again come back. And again come back. See, my dear student, and again come back. So what happened? If I'll throw a particle along y-axis, it achieves certain height and come back. So first, the direction of motion is positive y-axis. It stops at certain height and then again come back. Why I am using stop word? Because the direction of motion changes. And I already tell you, without come to rest, the direction of motion of particle never changes. So let's suppose this particle achieves this much height. Let's suppose this height is h, and this is the point where particle stops. So this point where particle stops is said to be maximum height. The point along y-axis where particle stops and again changes its direction of motion. Again changes its direction of motion, that point is considered to be maximum height. Now see, my dear student, this is the distance which is considered to be maximum height is along y-axis. Remember this thing, the point where particle stops and again its direction of motion changes, because see, in this situation the particle is moving, come to rest and again changes its direction of motion. So this point is considered to be maximum height. At this point the velocity of particle is equals to 0. I'll write here, at maximum height particle comes to rest, that is its velocity for certain time becomes 0, and from this maximum height the particle starts moving downward. So we'll say after achieving maximum height the direction of motion of particle changes. So I'll write here, after achieving maximum height, the direction of motion of particle changes. Remember this thing, after achieving maximum height the direction of motion of particle changes. Now the particle come towards earth, or we can say towards ground. In this situation particle is going upward, and in this situation particle is coming towards ground. So remember this thing, my dear student, at maximum height for certain time the value of velocity comes to be 0, because without become at rest the motion of direction never changes. Without velocity equals to 0, the direction of motion, remember dear student, never changes. That's why, see, one more thing what I'll tell you, that the particle is moving in upward side with some velocity and acceleration is continuously in downward direction. So if acceleration is continuously in downward direction, it implies the direction of velocity and acceleration is different, or we can say the direction of velocity and acceleration is opposite to each other. That's why continuously the speed of particle is decreasing, and at certain height which is called maximum height its velocity comes to be 0. Then the particle is moving in downward direction. See, in this situation when particle is moving in downward direction, its direction of velocity and acceleration is same. Remember this thing, if motion is under gravity, then when the particle is moving in upward direction, then its direction of velocity and acceleration is opposite to each other. But when the particle attains its maximum height and again come back towards ground, in that situation, my dear student, the direction of velocity and acceleration is same. Remember this thing, half of the motion when the particle is moving in upward direction, in that situation the direction of velocity and acceleration is different. After achieving maximum height, the particle come towards ground again. In that situation, the direction of velocity and acceleration is same. So remember this thing. This is how motion under gravity is explained, my dear student. This is somehow complicated topic. That's why I am saying this is logical topic. In first half means when the particle is moving upside. In that situation, the direction of velocity and acceleration is different, or we can say opposite to each other. That's why at certain height it come to rest, because continuously speed is decreasing, because I already tell you, if the direction of velocity and acceleration is different, then the speed of particle continuously decreasing. After achieving maximum height, the particle again come back towards ground. In that situation, the direction of velocity and acceleration is same. So if direction of velocity and acceleration is same, then the speed of particle continuously increasing. Moving forward, my dear student. So remember this thing, this point from where motion starts is called origin. This point is considered to be origin, and we know that origin carry value 0, 0. Above origin, all the values considered to be positive, and below origin, all the values considered to be negative. That's why we'll take acceleration due to gravity to be minus g, because this is along negative y-axis. And initial velocity is considered to be positive because it is along positive y-axis. So remember this thing, from this point to this point, this distance, this vertical distance is called horizontal, this vertical distance is called maximum height. And once the particle achieves maximum height, at that time the velocity becomes 0, and again the particle starts performing motion towards ground. So remember this thing, at maximum height the velocity is considered to be 0. The velocity is considered to be 0, and that velocity is nothing but final velocity. That velocity is nothing but final velocity when the particle is moving in upward direction. When particle is moving in upward direction. Now I'll write equation of motion in this situation, my dear student. Write down equations of motion with constant acceleration. See, only acceleration which is acting on particle when it is moving along y-axis is acceleration due to gravity, and this acceleration is constant. That's why we'll make equations of motion with constant acceleration, because we know that all the three equations of motion is only valid if acceleration is constant, and here only acceleration which is acting is acceleration due to gravity, which is a constant value. So I'll write here equation of motion, equations of motion with constant acceleration, equations of motion with constant acceleration. So in this situation, my dear student, initial velocity is considered to be plus v naught and acceleration is considered to be minus g, because the only acceleration which is acting on particle when the particle is moving along y-axis is acceleration due to gravity, which is minus g. Now I'll write equations of motion in this situation. See, we know that our first equation is nothing but v is equals to u plus at. So in this situation we'll write v is equals to initial velocity is plus v naught. So plus v naught, acceleration is minus g, so minus g into t. This is your first equation of motion when the body is throwing along y-axis from the ground. Similarly, if I write second equation of motion, so second equation of motion is nothing but s is equals to ut plus half at square. So instead of s, I'll write y, because s is nothing but displacement, and here displacement is always considered along y-axis. That's why I'll write y. So y is equals to u is initial velocity. We'll consider initial velocity to be plus v naught. So it is plus v naught into t, and instead of acceleration I'll write minus g. So it is minus half gt square. This is your second equation of motion with constant acceleration if body is throwing from ground and is moving along y-axis. Now moving forward, third equation of motion, it will be, my dear student, v square minus u square is equals to 2as. So v is your final velocity, u is your initial velocity, which will use v naught. So v naught square is equals to 2. Instead of a, I'll write minus g, and instead of s, I'll write y. So this is our third equation of motion with constant acceleration if the particle is throwing from ground and is moving along y-axis. So I hope you all understand all the equations of motion what I'll write. First equation is v is equals to plus v naught. Plus v naught is nothing but initial velocity. Why we are using plus? Because this is acting along positive y-axis. Why we are using negative in g? Because the acceleration due to gravity is x vertically downward along negative y-axis. So I'll use plus for positive y-axis and minus for negative y-axis. So these are the three equations of motion with constant acceleration if the particle is throwing along y-axis from the ground. I am repeating once again. First equation, v is equals to plus v naught minus gt. Plus v naught is nothing but initial velocity, minus g is nothing but acceleration due to gravity. Second equation of motion is y is equals to plus v naught t minus half gt square. Y means displacement is along y-axis because we are dealing with motion under gravity, or we can say motion along y-axis. That's why I'll use y here. Nothing special in this. Plus v naught t minus half gt square. Again plus v naught is nothing but initial velocity of particle which is acting along positive y-axis, and minus g is acceleration due to gravity which is acting along negative side. That's why I'll use minus. And third equation is v square minus v naught square is equals to minus 2gy. Y is nothing but displacement along y-axis. G is acceleration due to gravity along with negative sign, which implies this direction acceleration due to gravity is always x vertically downward. V naught is your initial velocity and v is your final velocity. So I hope you all understand all the equations of motion with constant acceleration. Now we are deriving some important formula in this situation. So write down important formula. If the particle is moving along y-axis, if the particle is moving along y-axis with some initial velocity, So see, my dear student, if a particle is throwing, it means we are giving some initial velocity to the particle. Our initial velocity is plus v naught. I already tell you this point is considered to be origin where all the value is 0. So 0, 0. Only acceleration which is acting on particle is minus g. So the particle starts performing motion along y-axis. It come to rest at certain point. This point is called maximum height, and we know that, my dear student, this distance is h and this distance is along a y-axis. So if this distance is along y-axis, then its coordinate, this point maximum height coordinate will be 0, h. Remember this thing, 0, h. Why h? Because this distance is along y-axis. So on y-axis 0, that's why I'll use 0, and instead of y I'll write h because this distance is considered to be h. Now see, my dear student, let's suppose from origin to maximum height the particle reaches by taking some time t is equals to t1. At maximum height, for certain time the particle stops and again come back towards ground. Let's suppose from maximum height to ground the time taken by particle is t is equals to t2. T is equals to t2. See, my dear student, the time taken by particle from ground to maximum height is t1, and from maximum height to again ground it is t2. The only acceleration which is acting on particle is minus g, and the initial velocities of particle is considered to be plus v naught. Remember this thing, the coordinate along y-axis at maximum height is 0 comma h. And one more thing, after achieving maximum height, the direction of motion changes. So we will say at maximum height, for some time, for certain instant of time, the velocity of particle is equals to 0, because without coming to rest, the direction of motion never changes. So t1 is going time and t2 is coming time. So if I'll add t1 plus t2, it becomes equals to capital T, which is also called time of flight, time taken by particle to reaches at same point from where it start its motion. So I'll say first thing which we introduce is time of flight, and time of flight is represented by capital T. So capital T is nothing but T1 plus T2, and we know that T1 is going time from ground to maximum height, and T2 is nothing but time taken by particle to time taken by particle from maximum height to ground. So time of flight is nothing but total time taken by particle to complete its motion. Total time taken by particle to complete its motion. And completion of motion means the initial velocity and final velocity must be equal to is same. The initial point and final point become same if we are talking about time of flight, because time of flight is nothing but total time taken by particle to reach again on its initial position. I'll write here time of flight. So time of flight is total time taken by particle to reaches on its initial point. Is called time of flight. Now my dear student, I'll find time taken by particle to reaches at maximum height. So write down heading time taken by particle to reaches at maximum height. Time taken by particle to reaches its maximum height. Now see my dear student, the time taken by particle to reaches its maximum height is considered to be t1. So instead of t, I'll write t1. Instead of initial velocity, I'll write plus v0. Instead of y, I'll write h, because h is maximum height. And instead of acceleration, I'll write minus g. Why minus g? Because my dear student, the particle is moving along y-axis, and if particle is moving along y-axis, then its acceleration is always along negative y-axis. And now see, at maximum height, I already tell you the velocity is equals to 0, because after achieving maximum height, the direction of motion of particle changes. Now the particle will be attain the direction of motion towards downward, towards ground. So final velocity is considered to be 0 by equation of motion, first equation of motion, and we know that first equation of motion is v is equals to u plus at. So instead of v, I'll write 0, instead of u, I'll write plus v0, instead of a, I'll write g, and instead of t, I'll write t1, because we are finding the value of t1, time of flight, or time taken by particle to reaches its maximum height, which is t1. So minus gt comes this side, so it will be plus gt, which will be equals to plus v0. So t1 is equals to nothing but v0 by g. This is the value of time taken by particle to reaches its maximum height from ground. I hope you all understand this derivation. T1 is nothing but time taken by particle to reaches its maximum height from ground, and it is equals to plus v0 by g. We know that v0 is nothing but initial velocity of particle. v0 is nothing but initial velocity of particle. Now moving forward, we'll find the value of maximum height. Write down next, maximum height. maximum height. So maximum height, if I am talking about maximum height, then we know that the value of y is plus h, the value of initial velocity is plus v naught, and at maximum height we know that final velocity is nothing but equals to 0, my dear student. So now we have to find maximum height attained by particle. So by third equation of motion, which is v square minus u square is equals to 2as. See, my dear student, v is final velocity. For maximum height we know that final velocity is 0, initial velocity is plus v naught square, which will be equals to 2 into minus g into, instead of s I'll write y. As simple as this. So what it will be? Minus v naught square is equals to minus 2gy. So instead of y I'll write h, because y is vertical distance and the vertical distance is nothing but h. So minus minus get cancelled. So v naught square is equals to 2gh. So h is equals to v naught square by 2g. This is the formula for finding maximum height attained by particle if you are throwing a particle towards y-axis. So maximum height is v naught square by 2g. v naught is initial velocity, 2 is constant, and g is nothing but acceleration due to gravity. Now we are finding total time of flight. Total time of flight means t1 plus t2, time taken by particle to reach maximum height, and from maximum height time taken by particle to reach again at ground. So write down next heading, it is time of flight. I hope you all are understanding all these equations, because these equations are quite logical but not tough. So write down time of flight. Write down time of flight. Time of flight. So we know that time of flight is nothing but capital T, which is equals to t1 plus t2. Time taken by particle from ground to maximum height, and time taken by particle from maximum height to again come towards ground. This total time is called, my dear student, time of flight. So instead of t, I'll write capital T, and see, my dear student, if the particle starts from its motion from O, because O is considered to be origin, go to maximum height and again come back to O. So this time and this time is considered to be time of flight. So once we are talking about time of flight, then the value of y is 0, because time of flight is nothing but going time and come back time. So total time taken by particle to complete its motion is called time of flight. So time of flight means here, when particle reaches here at this point, and at this point we know that y is equals to 0, because this point is considered to be origin, and we know that origin carries 0 value. So y is considered to be 0. Again, initial velocity is nothing but v naught. So write down by second equation of motion. We know that second equation of motion is y is equals to ut plus half at square. Instead of a, we know that we'll write minus g, because only acceleration which is acting on particle when the motion is along y-axis is minus g. Minus means negative direction. So y is 0, initial velocity is plus v naught into capital T plus half. Instead of a, I'll write g, again t square. So 0 is equals to v naught capital T minus half gt square. This value comes this side, so it will be half gt square is equals to v naught t. 1t get cancelled. It will be capital T is equals to v naught and 2 divided by g. So time of flight is nothing but 2 v naught by g. Time of flight is nothing but 2 v naught by g. So this is the value of time of flight, and time of flight means total time taken by particle to reach again at ground. Now moving forward, time taken by particle from maximum height to ground. We'll find now time taken by particle to reach from maximum height to ground. Maximum height to ground. So we are now finding the value of T2. We know that capital T is nothing but T1 plus T2. So we know the value of T1. The value of T1 is nothing but V0 by G, which we already find it. So the value of T1 is equals to V0 by G, and the value of capital T is 2V0 by G. So my dear student, capital T is equals to T1 plus T2. So T2 must be right T minus T1. So T2 is equals to 2V0 by G minus V0 by G, because T is total time of flight, or we can say time of flight, and the value of time of flight is 2V0 by G, and the value of time taken by particle to reach maximum height is T1, which is equals to V0 by G, which we already find it. So T2 is equals to nothing but V0 by G. So this equation implies the time taken by particle from ground to maximum height is always equals to time taken by particle to maximum height to again reaches at ground, because the value of T1 and T2 is same. So write down, my dear student, the time taken by particle, write down the time taken by particle from maximum height to ground, the time taken by particle from maximum height to ground, time taken by particle, time taken by particle from ground to maximum height, from ground to maximum height is equal to time taken by particle from maximum height to ground again. So I hope you all understand all these equations. I hope you all understand all these equations. So first thing what we will find is total time taken by particle from ground to maximum height. It is equal to V0 by G. What is V0? V0 is initial velocity. Then we will find time taken by particle from maximum height to ground, which is again equals to V0 by G. V0 is initial velocity and G is acceleration due to gravity. So what we conclude here, my dear student, will concluded that the time taken by particle from ground to maximum height and maximum height to ground is same, which is equals to V0 by G. Then we will find total time of flight. Total time of flight means time taken by particle to reach again its initial position. It will be equals to 2V0 by G. So V0 is nothing but initial velocity of particle and G is acceleration due to gravity. Then we will find maximum height attained by particle. So the value of maximum height attained by particle is equals to, my dear student, V0 square by 2G. Again V0 is initial velocity and G is acceleration due to gravity. Its value is 10, or we can say 9.8 meter per second square. So these all equations are very important, and these equations are derived under condition when the particle is moving in motion under gravity, or we can say we are throwing a particle by giving some initial velocity. So case 1 is completed. Now moving forward to case 2. If a body is dropped from certain height, write down case 2. If a body is dropped, write down case 2. If the body is dropped from certain height, if the body is dropped from certain height. Now my dear student, word drop is there. So if word drop is there, then it means we are not giving any velocity to the particle. In that situation, initial velocity is considered to be 0. So moving forward, we are talking about case 2, and our case 2 is if a body is dropped from certain height. If a body is dropped from certain height. Now I'll write in form of note. If we are dropping a body, if we are dropping a body, it means initial velocity. It means initial velocity is equal to 0. If we are dropping a body, it means initial velocity is equals to 0. Now see my dear student, let's suppose we have a building like this. Let's suppose the height of building is h, and this is the point from where we are dropping a body. So see, for this point is now considered to be origin. For us, this point is origin, and this point is final point. This is our initial point and this is our final point. Remember this thing, this is our final point. So see, the direction of motion is negative side. Negative side, my dear student, because this is y-axis, and above y-axis we know that positive value, and below y-axis it is negative. So this is positive, this is negative. So the direction of motion now in this situation is towards negative side. So this point carry x coordinate 0 and y coordinate carry minus h. Why minus h? Because this is the vertical distance along y-axis, but in negative side, because now the point which is present above building is considered to be, my dear student, origin. See, we are dropping, so initial velocity is nothing but equals to 0. In this situation I am writing equation of motion. So write down equation of motion with constant acceleration. With constant acceleration. Again, in this situation as well, only acceleration which is acting on particle is acceleration due to gravity, and its direction is towards negative y-axis. That's why I'll write minus g. Instead of acceleration, we'll put the value minus g. This point is considered to be origin, and if this point is considered to be origin, then this point carry value 0, 0. Initial velocity is considered to be 0, my dear student, because we are dropping a particle. And if you are dropping a particle, you are not giving any velocity. That's why initial velocity is considered to be 0. So first equation must be v is equals to u plus at, but in this situation u is 0, so I'll write v is equals to minus gt. For this situation, this is our first equation of motion. Second equation is nothing but y is equals to ut plus half at square. So instead of u, initial velocity, as we are dropping the particle, so it is 0. So y is equals to half gt square, and along with minus sign, this is our second equation of motion for this situation. Third equation is v square minus u square is equals to 2ay. Instead of s, I'll write y. So write down s. So instead of v minus, instead of u, will put 0 minus 2gy. So we'll write v square is equals to minus 2gy. This is our third equation of motion for this situation. I am repeating again and again, my dear student, we are dropping the particle. So if you are dropping a particle, then it implies its initial velocity is nothing but equals to 0. So remember this thing, equation of motions in this situation is first v is equals to minus gt, v is final velocity, g is acceleration due to gravity, and t is time taken by particle to reach from maximum height, from this top of the tower to the ground of the tower. The second equation is y is equals to minus half gt square, and third equation is v square is equals to minus 2gy. Moving forward, now we are deriving some formula. Write down first formula, time of flight. Time of flight. So time of flight is nothing but time taken by particle to reach from top of the tower to the bottom of the tower. Write down first time of flight. First equation, first formula which we derived here is time of flight. Time of flight, it is represented by capital T. So total time taken by particle, total time taken by particle to reach from top of the tower to the ground of the tower. Ground of the tower. Total time taken by particle to reach from top of the tower to the ground of the tower is called time of flight. Now my dear student, by equation of motion, I'm using second equation of motion, which is y is equals to ut plus half at square. We are dropping, that's why initial velocity is 0. Instead of y, I'll write minus h. So minus h is equals to minus half gt square, minus minus get cancelled, my dear student. It will be 2h by g is equals to t square. So t must be equal to under root 2h by g. This is the value of time of flight, that is time taken by particle to reach from top of the tower to the bottom of the tower. H is height of the tower, or we can say vertical distance, because y-axis is nothing but vertical axis and x-axis is nothing but horizontal axis. So this is first equation or first formula which we derived. Next, velocity acquired by particle just before reaching the ground. Write down next heading, velocity acquired by particle, velocity acquired by particle just before reaching the ground. Velocity acquired by particle, velocity acquired by particle just before reaching on ground, velocity acquired by particle just before reaching the ground. My dear students, see, once the particle reaches at ground, then its velocity again comes to 0. I am repeating once again. Once the particle reaches at ground, if particle reach at ground, in that situation its velocity is 0. Simple, because if the particle reaches at ground, it can come in rest condition, and in rest condition we know that velocity is equals to 0. But before reaching the ground, just above the ground, it not be in rest condition. It must carry some velocity. My dear student. We are interested to find that velocity only. That velocity which is achieved by particle just before reaching the ground, because we know that once the particle reaches at ground, then its velocity is 0. Simple. But when the particle not reaches at ground, just above the ground, in that situation the particle carries some velocity. We are interested to find that velocity, my dear student. So velocity acquired by particle just before reaching on, write down in form of note. Once the particle reaches on ground, write down, once the particle reaches on ground, its velocity is equals to 0. Its velocity is equals to 0. But just above the ground, it carries some velocity. But just above the ground, it carries some velocity. So we are interested to find that velocity only, my dear student. So let's suppose that velocity is equals to v0. We are assuming that that velocity must be v0. Write down v as well. So by second equation, or we can say third equation of motion. Use third equation of motion, because we know that the time taken by particle to reaches just above the ground is capital T, which is equals to under root 2h by g. This value we know about this value. Time taken by particle just before reaching the ground. It is equals to under root 2h by g. So we are using equation here, first equation of motion. Use first equation of motion, which is which is nothing but v is equals to u plus at. Instead of u we will put value 0, because we are dropping the particle. So it is v is equals to minus g capital T. So v is equals to minus g. Instead of capital T, I'll write 2h by g. Now I am taking this g inside the root, so it will be g square. So my dear student, the value becomes v is equals to minus under root 2g square by h, g get cancelled. What will get? V is equals to minus 2j. See, this negative sign implies that the direction of velocity is negative side. That's why here negative sign comes, my dear student. So before reaching the ground, the velocity of particle is nothing but under root 2gh. G is acceleration due to gravity and h is vertical distance which is covered by particle. And this negative sign shows that the velocity just before reaching the ground, which is equals to under root 2gh, is towards negative side, because this is origin, and above origin we know that positive and below origin we know that negative. So this is all about all the formulas which is related to motion under gravity. We left with only one case, which is if I am giving some velocity, or we can say if we are throwing a particle from certain height. In this situation we are dropping the particle. In next class we will discuss what if we are throwing any particle. So remember this thing, my dear student, motion under gravity is not a very tough chapter portion. It is just a simple conceptual question. So if you are work on concept, then you will commanded on motion under gravity, and it is easy for you to understand projectile motion, which is also called motion in plane, because these are very similar topic. Here also only acceleration which is acting on particle is acceleration due to gravity, and once we are starting projectile motion, there also the only acceleration which is acting on particle is acceleration due to gravity. So I hope you all understand this topic, my dear student. Thank you so much for connecting with us. Stay home, stay safe, take care. We'll meet in next class. Next topic will be our motion under gravity, last case, if I am throwing a particle from certain height. So if you are capable, you are understanding all these concepts, then try to solve, find all the values, all the equations of motion if you are throwing a particle from certain height. So thank you so much. We'll meet in next class with new topic. Thank you, my dear student.